All right, today we're doing synthetic division, which is a take on long division like we did yesterday, or Friday, excuse me. This one says use long division, so I'm going to show you how to do long division again, just to remind you, and then I'll move into synthetic division. So for long division, we put our factor outside, and then we put our big division bar, and we write what we want to divide inside, okay? And then we ask ourselves, we say, how do we get x to become an x cubed? And we need an x squared. And then we multiply. X times x squared is x to the third. Negative 2 times x squared is negative 2x squared. But we have to remember that this is subtraction, so that changes to a plus sign. So those cancel. 5x squared plus 2x squared is 7x squared. And then you bring the next thing you haven't used down. And now we're going to ask ourselves the same thing. How do we get an x to become a 7x squared now? And we need a 7x. We write that up top. And then we multiply x times 7x is 7x squared. Negative 2 times 7x is negative 14x. And then remember, we're subtracting, so that turns to a plus. So those cancel, and I'm left with 12x. And then I have to remember to bring down the next thing I haven't used. And then I ask myself again, how does an x become a 12x now? And that means I need to multiply by 12. So x times 12 is 12x. Negative 2 times 12 is negative 24. And last, again, we need to remember that we're subtracting, so that becomes a minus. That becomes a plus. And how convenient, everything cancels, which means it's a factor. Okay? Now, the only thing we're adding from Friday is that we're going to write our answer the same as we did before. X minus 2 is what we factored out. And our final answer is x squared plus 7x plus 12. But we have to go back and remember that sometimes this can factor, so we're going to use our diamond. 12 goes on top, 7 goes on the bottom, and remember we're trying to multiply to 12 and add to 7, so we get 3 and 4. So our final factored form is x minus 2. This factors to x plus 3, x plus 4, and the reason I want to completely factor it is because now I know my roots are at 2, negative 3, and negative 4. Okay, and that's why I would want to completely factor it, whereas Friday I just wrote most of my answers with just division. Okay, so now we're going to move on to an example of synthetic division. So this is the same example, but with synthetic division. And if it's x minus 2, the root is at 2, so that's why we put a 2 outside, and it's going to look funny. But you always write your coefficients out. So 1 goes with the x cubed, 5 goes with the x squared, negative 2 goes with the x, and negative 24 is off by itself. And then you don't need to follow this pattern right now, but it's you always bring the first coefficient down, and these little lines you multiply, and then the 5 and the 2 here, you always add them. You always add these together. Okay, and you'll see the process completely. So this one says that x cubed minus 7x squared plus 2x plus 40 has a 0 at 5. So 5 is going to go outside, and then I make this box type thing. Okay, and so what I do is I write my coefficients. There's really a 1 in front of the x cubed, a negative 7 in front of the x squared, a 2 in front of the x, and 40. Okay, I always, 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 no matter what number's in front, bring it down first because I have to start. And then I say, all right, 5 times 1, I multiply, is 5. And then I'm always, always, always adding these. Negative 7 plus 5 is negative 2. Then I go and I say, all right, 5 times negative 2 is negative 10. And I'm always, always, always adding these. So I get negative 8. And then I say, all right, 5 times negative 8 is negative 40. And I get a remainder of 0, which means that my answer worked out. Now what this means is, if I have a 0 at 5, my answer has to have an x minus 5 in it because that gives me a root of 5. Okay, this part, the 1, the negative 2, and the negative 8, gives me the second part of my answer, which is 1x squared, because if I started with an x cubed and I divided by an x, it's like I took away an x, so I'm left with x squared minus 2x minus 8. So that would be my answer if I just left it, but remember I need to remember to factor. So I'm going to use my diamond, and I'm going to factor this. I get a negative 8 on top and negative 2 on the bottom, and my factors are negative 4 and positive 2. So my final answer, I'm keeping the x minus 5 because they already told me a root was at 5. And now I'm going to write this out in factored form, which is x minus 4, x plus 2. And now I know my roots are at 5, 4, and negative 2, which all that means is I have, it crosses at 5, 4, and negative 2. So you could draw any graph you want, really, as long as it crosses. We haven't gotten into the logistics of what the graph's going to look like. So all you know right now is that the graph crosses at negative 2, 4, and 5. All right, let's try one more together and have you pause it and try it on your own. So the first one, I write out my coefficients. 1, negative 3, negative 9, 27. Okay. Then I bring the 1 down, always. Always bring the first number down, even if it's not a 1. And then you start your multiplication. 3 times 1 is 3. Negative 3 plus 3 is 0. 3 times 0 is 0. Negative 9 plus 0 is negative 9. 3 times negative 9 is negative 27, and I get a remainder of 0. So I write my answer like this. If it has a root of 3, that means the original parenthesis must have been x minus 3. And remember, I started with an x cubed and took away an x, so I'm left with a 1x squared plus 0x minus 9. And that would have been my answer, but remember I need to factor if I can. And if you remember, this is one of those special ones. So I'm going to keep my x minus 3. The x squared minus 9 is an x plus 3 and an x minus 3. Okay, which means I have a root at 3, a root at negative 3, and I have to write 3 again, but that really just means, remember, that this is a double root. Okay, so if I want to sketch a graph, it crosses at 3 and negative 3. And it's a double root, so remember it hits and bounces back. And we haven't done anything with what the graph should look like in terms of up or down or whatever, okay? Don't forget the new step though, which is to just factor. So let's try this last one and show you when we have to do it twice. So if they tell you there's 2 zeros here, a negative 2 and a 3, you just do it once and then the other one. Okay, so I'm going to start with the negative 2 and write my coefficients out. 1 x to the 4th, negative 4 x to the 3rd, negative 13, 28, and 60. Always, always, always bring the first number down. And I get the 1. Now I start my multiplication. Negative 2 times 1 is negative 2. And I'm always adding, so that's negative 6. And then I got negative 2 times negative 6, which is 12. And again, I'm always adding, so I get negative 1. Now I have 2 times negative 1, or negative 2 times negative 1, which is positive 2. That gives me 30. And then the last thing I have is negative 2 times times 30, which is negative 60. And I get a remainder of 0. Okay? So right now I have a root at x plus 2. Okay, now I'm going to copy these coefficients up here because I'm going to do it again. So I'm going to take my root of 3 and put it outside, and I'm going to copy the 1, the negative 6, the negative 1, and the 30, and do the same process again. Always bring the first number down, gives me 1, and then start your multiplication. 3 times 1 is 3. Negative 6 plus 3, remember you're always adding, is negative 3. And it's 3 times negative 3, which is negative 9. Add down, which is negative 10. And then lastly, it's 3 times negative 10, which is negative 30. Always add, and I get a remainder of 0, which means I'm going to have a nice answer. It also means that I have a root at positive 3. So if it's at positive 3, when I write it in my factored form, I write minus 3 in my parentheses. And since I started with an x to the 4th, when I did it once, I was down to an x to the 3rd. When I did it again, this must stand for an x to the 2nd. So I have 1x to the 2nd minus 3x minus 10. And remember, the step we're adding today is not only the new division, but to have to factor your answer completely. So let's see if we can find some factors that multiply to negative 10 and add to negative 3. I think that's negative 5 and 2. So this factors to x minus 5, x plus 2. And I already know, because I got a remainder of 0, that x plus 2 was a factor and x minus 3 was a factor. All this tells me, like I did before, is that I have a root at negative 2, a root at positive 3, a root at positive 5, and a root at negative 2. Okay, and that negative 2 is called a double root because it's occurred twice. Okay, you can use your calculator to type this in as well if you'd like to, or sketch a graph. The big goal is synthetic division today though, so if you don't quite get the graphs, that's fine. All right, why don't you pause the video and try this one on your own. This is a double step one. So you have to do it once, take your answers that you get from right here, and put them again right here. Okay, so go ahead and try this, and then we'll see how you did. All right, you write your coefficients, 1, 3, negative 13, and negative 15. And notice that there's no term on the end, number, so we're going to write 0. So technically after the x there should come a number. If you didn't write the 0, it wouldn't be a big deal. Okay, always bring the first number down. Gives me 1. 3 times 1 is 3. Always add. 3 plus 3 is 6. 3 times 6 is 18. Negative 13 plus 18 is 5. And 3 times 5 is 15. Negative 15 plus 15 is 0. And 3 times 0 is 0. I get a remainder of 0. So that means that 3 was a factor. It means it crosses the graph at 3. And I'm going to take all these coefficients and copy them. 1, 6, 5, 0. And I'm not going to copy that 0 because it's just my remainder. And I repeat the process. Copy the 1 down. Negative 1 times 1 is negative 1. 6 plus a negative 1 is 5. Negative 1 times 5 is negative 5. 5 plus negative 5 is 0. Negative 1 times 0 is 0. 0 plus 0 is 0. So that means I have a remainder of 0. And negative 1 is also a root of my graph. Now this is the tricky part on this one. 3 is a root, so that means it has to be x minus 3 in the equation. Negative 1 is a root because I got a remainder of 0, so that must be x plus 1 in the equation. And now you have to figure out how to write the 1, the 5, and the 0. It started as an x to the 4th. That means this was an x to the 3rd. and you can see it fits. And then when I did it again, that means I took another x away. So this must be an x squared, this must be an x, and this must be just a regular number. So how I write that 1 and 5, it's 1x squared plus 5x plus 0. Okay, and this one we actually don't use the diamond to factor because there isn't going to be anything that multiplies to 0 and adds to 5. So we just have to factor out what's in common. So x minus 3 stays. X plus 1 stays because it's completely factored, and I can take an x out of this one. So this would be my final factored form because the x squared plus 5x, I just factored an x out. So I have a root at 3, a root at -1. This one is 0, and a root at -5. So my final answer is this factored form, and all it tells me is my roots, or in other words, where it crosses the x-axis. Okay, your homework today is going to be synthetic division worksheet. It's attached to your one from Friday. Don't worry about the exit slip unless you want another one to practice. So if you want to do this one, go ahead. Otherwise, I've laid out the first two on your assignment on the board so you can see some work. Okay, have a good day.